Hello students, in this video I am going to explain vapor pressure of liquids and Raoult's law, relative lowering of vapor pressure. Please subscribe to my channel, like, share and comment my videos.
Now let us discuss about vapor pressure. Imagine this situation. This is a vessel in which this is the liquid. Of course, this is the surface of the liquid. Surface of the liquid. The surface of the liquid also has liquid particles, molecules. So these molecules, the molecules on the surface of the liquid, they tend to move out. That means they have attractive force in three different directions. The attractive force in this manner, in this manner, in this manner. Whereas there is no attractive force on the surface. Right. So as unequal forces are acting here, therefore the molecule tend to move out. Molecule tend to move out. As the molecule moves out, this is nothing but this is in a gaseous state. Gaseous state means vapor phase. In this case, the vessel is not closed. As vessel is not closed, the particles which are escaping from the surface of the liquid, they go out. That is, they do not come back. Now, if we keep a lid, if this vessel is closed in this manner, vessel is closed. If vessel is closed, the liquid particles, the particles which escape from the surface, they are trapped within the empty space above the liquid. Right. The particles in vapor phase, they are trapped within the empty space above the surface. Now what happens? This space is filled with vapor particles or gaseous particles. So that what happens? After some time, these vapor particles come and enter into the liquid, whereas the liquid changes to vapor. That means the liquid changes to vapor and vapor changes to liquid. That means the vaporization process continues such that the liquid and the vapor both are in equilibrium. Both are in equilibrium. Right. Now, whenever the vapor starts entering into the space above the surface, what happens? They start exerting pressure in this manner. Pressure. Now, during the equilibrium, the pressure exerted by vapor during the equilibrium is known as vapor pressure. So, how do we define the vapor pressure? Vapor pressure So vapor pressure is the pressure exerted by vapor over the surface of the liquid when it is in equilibrium with the liquid at a given temperature, and of course this is the vapor pressure. So as this is the vapor pressure, now we dissolve some non-volatile solute. So this is the liquid. So here this is liquid plus non-volatile solute. So as non-volatile solute is present in the liquid, and of course these are the particles. Now imagine when it is a pure liquid, all the surface is occupied by liquid molecules. As the liquid is mixed with non-volatile solute, do you expect that all the particles on the surface is occupied by liquid molecules? No, not exactly. So what happens? Some of the surface is occupied with solute particles also. Some of the surface is occupied by solute particles. So here the completely darkened circles indicate the solute particles. Solute particles do not escape. As they are non-volatile solute, they do not escape and they do not form the vapor. Right. Now what happens? Okay, this is closed with a lid. Now what happens? As the surface becomes less for liquid particles, the vaporization process also becomes less. So here vaporization also less. When vaporization less, vapor pressure also less. So why vapor pressure is less when it is mixed with non-volatile solute? Because when non-volatile solute is mixed with a pure solvent, some of the surface is occupied by solute particles also. Therefore, they do not escape, they do not form vapor. Therefore, the surface for the vaporization of the liquid becomes less. As the vaporization process becomes less, vapor pressure also less. Thus, from this it is observed that vapor pressure of the liquid becomes less when it is mixed with a non-volatile solute. Therefore, vapor pressure of a liquid is less when compared to pure liquid. When it is mixed with non-volatile solute. So when a pure liquid is mixed with a non-volatile solute, then its vapor pressure becomes less when compared to the vapor pressure of the pure solvent. Now let us see the factors affecting the vapor pressure of liquid. So number one, vapor pressure of the liquid depends on the nature of the liquid. Nature of the liquid means if the intermolecular forces are weaker. So intermolecular forces are weaker, then what happens? Vaporization process becomes more. Therefore vapor pressure is more. So smaller the intermolecular forces, greater is the vapor pressure. Therefore we can relate smaller the intermolecular forces implies greater is the vapor pressure. Right. Now for example, dimethyl ether, vapor pressure of dimethyl ether is more, whereas vapor pressure of ethyl alcohol is less. When compared to in between these two substances, dimethyl ether has more vapor pressure, ethyl alcohol has less vapor pressure. Effect of temperature. If temperature increases, vapor pressure also increases. Why? If temperature is more, kinetic energy of the molecules is more. If kinetic energy increases, then what happens? Molecule tends to come out of the surface quickly. That means vaporization process becomes more. As vaporization becomes more, vapor pressure is more. Therefore vapor pressure is more. So these are the factors affecting the vapor pressure of the liquid. One is nature of the liquid and another one is temperature. If temperature increases, vapor pressure increases. Therefore vapor pressure is directly proportional to temperature. Just now we discussed that vapor pressure of liquid containing non-volatile solute is less than the vapor pressure of pure liquid. Vapor pressure of pure liquid. Vapor pressure of pure liquid. Vapor pressure of liquid containing non-volatile solute. Non-volatile solute. Let it be PA. A is a component that is a solvent, whereas vapor pressure of liquid, this is pure liquid. Vapor pressure of pure liquid. Vapor pressure of pure liquid is P0A. So, as we discussed just now, the vapor pressure of the liquid containing non-volatile solute is less than the vapor pressure of the pure liquid. So, this is referred as lowering of vapor pressure. Lowering of vapor pressure. So, what is the lowering of vapor pressure? Lowering of vapor pressure equal to the difference between P0A and PA. That means the difference between vapor pressure of pure liquid and vapor pressure of the liquid containing non-volatile solute is referred as lowering of vapor pressure. This is denoted by delta P. Delta P. When two volatile liquids are mixed to form a solution. That is liquid A and liquid B. Now the vapor pressure of pure liquid A is P0A. Similarly, vapor pressure of pure liquid B equal to P0B. Right. Now, when two liquids are mixed with each other, the mole fraction of A equal to XA, mole fraction of B equal to XB. Mole fraction of B equal to XB. Right. Total mole fraction equal to XA plus XB is equal to 1. So if a number of components are mixed with each other, the mole fraction, the sum of the mole fractions of all the components is equal to 1. So whenever a volatile or non-volatile component is mixed with a solvent, then vapor pressure of liquid containing non-volatile solute is proportional to vapor pressure of pure solvent. That is, so vapor pressure of solution equal to here proportionality can be removed by mole fraction, a constant mole fraction into vapor pressure of pure solvent. So here vapor pressure of solution is equal to P0, PA is equal to XA into P0A. XA is the mole fraction, P0A is the vapor pressure of pure solvent. Right. Now PA is equal to, previously what we discussed, XA plus XB is equal to 1, XA equal to 1 minus XB. So in place of XA, we can keep 1 minus XB into P0A. So this is PA equal to P0A minus XB into P0A. Right. Now bring this to this side. So XB P0A is equal to P0A minus PA. What is P0 minus PA? It is nothing but delta P. Delta P means lowering of vapor pressure. Now XB equal to delta P by P0A. That means XB is equal to P0A minus P by P0A. So what is this? This is the ratio between lowering of vapor pressure to the vapor pressure of a pure liquid. Therefore, this is referred as relative lowering of vapor pressure, RLVP, relative lowering of vapor pressure. Therefore, relative lowering of vapor pressure is the ratio of lowering of vapor pressure to the vapor pressure of pure liquid. So this is nothing but the Raoult's law. Now let us define the Raoult's law. Raoult's law states that the vapor pressure of a solvent or liquid containing a non-volatile solute is directly proportional to the mole fraction of the solute. So according to Raoult's law, RLVP is equal to delta P by P0A. This is nothing but P0A minus PA by P0A. So this is the ratio between the lowering of vapor pressure to the vapor pressure of pure solvent. Now, based on this, we can define the Raoult's law in a different way also. So, Raoult's law for a solution containing a non-volatile solute, the vapor pressure at a given temperature, is, so for a solution containing a non-volatile solute at a given temperature, relative lowering of vapor pressure is equal to the mole fraction of the solute, that is non-volatile solute. Therefore, Raoult's law can be defined in this way also. Now, in place of non-volatile solute, if we take two volatile liquids, so for a binary solution with two volatile liquids A and B. So vapor pressure of liquid A is equal to P0A, vapor pressure of liquid B equal to P0B. On the other hand, mole fraction of A equal to XA, mole fraction of B equal to XB. So total mole fraction equal to XA plus XB is equal to 1. Now, vapor pressure of liquid A in the solution. Vapor pressure of liquid A in the solution is PA. PA equal to XA into P0A. Similarly, vapor pressure of B in the solution, PB, is equal to XB into P0B. Therefore, total vapor pressure of the solution, PA plus PB is equal to XA into P0A plus XB into P0B. So this is total vapor pressure. Total vapor pressure PA plus PB equal to XA into P0A plus XB into P0B. So when P0A becomes a KH, then Raoult's law is the special case of Henry's law.